Imagine asking your AI three questions at the same time and watching the answers stream live, token by token, in different colors, like a magic on your terminal. In this episode, we are building that exact pipeline using LangChain version 0.3 plus, using streaming and async. A live parallel trivia that streams answers in real time like a quiz show in your terminal. We are combining modular LCEL chains, async programming, streaming responses, structured output parsers, all in one project. By the end, you will see multiple questions being answered simultaneously, token by token, with each answer color coded for clarity. When I built this, I learned so many concepts which I have never touched before, like async streaming, parsers, etc. And now I am going to explain all of it to you step by step. By the end of this video, you will not only understand these concepts, but you will be able to build your own real-time interactive AI pipelines from scratch. Alright, first things first, we need a solid foundation for our trivia bot. We are using Poetry to manage the dependencies and keep our project clean. The reason for using Poetry is it's not just a package manager, it's a dependency and virtual environment manager. Everything stays clean and reproducible, so no more it works on my machine headaches. I know some of you might ask, can't we use UV instead? Yes, technically you can use UV, but Poetry gives us a tight control over the dependencies and the versions and the scripts inside a pyproject.toml file. That's why for a professional project like this, I would strongly recommend using Poetry. First, let's scaffold our project, guys. We will write this command. This particular command has the Poetry keyword and the new keyword, which means a new project will be created, and we are specifying that we need an src directory inside this project. See, we have it, and we are specifying the project name. With this name, the folder will be created, and it is also saying the src option is now the default and will be removed in a future version. That means in the upcoming Poetry versions we need not specify this minus minus src keyword, guys. Now let's enter the project folder cd. Let's open this folder in a new VS Code window, guys. Code dot. Executing this command will open a new VS Code window in this directory, instant trivia bot. See, we are there. Now let's talk about the project structure, guys. Poetry by default gives us this template, this kind of template. It has a pyproject.toml file, which is heart of our project, and this is the src directory in which there is an instant trivia bot directory. Inside this only we will be writing our source code, guys. This is how professional projects are built. We maintain all the source code inside an src directory. And coming to pyproject.toml file, this file will contain all the details about our project, all the dependencies which we need for our project. See, here it is named instant trivia bot, the project name. It also given the version. We can write our own description. We can specify the author names. It is our email, our name and our email. We are specifying the Python version as 3.12, and also whatever dependencies we want for this project we will be specifying in this dependencies array. And to save time and avoid the installation headaches, I have prepared a pyproject.toml file with all the dependencies we need. I am pasting that code here, guys. You can get this source code from our GitHub repository and the link is in the description. Now let's look at what this pyproject.toml has. We have specified the dependencies we want, like LangChain, OpenAI, .env, python.env. We need pydantic, we need rich. This particular package is, guys, rich. It will style the text inside this terminal, because the outputs for our project we will be seeing in the terminal only, and this rich is a package that makes the output of the terminal look beautiful. Just replace the pyproject.toml file in your project with this one and we are good to go. This way Everyone is working with the same version of LangChain, OpenAI and other dependencies. Now let's save it. Now it's time to install all these dependencies. To install this, we should write poetry install. So it's done with installing, guys. What poetry actually did is it created a virtual environment and also created a poetry.log file. This particular file will ensure that wherever you deploy this project, this whole project, this poetry.log file ensures that the same versions which we have mentioned here, only those versions will be installed. And that's it. Now we are ready to start coding, guys. And for this project, we will need an OpenAI's API key and we will have to safely load that OpenAI's API key into our project. We should never hard code that API keys into our source code, guys. It is a bad practice. So instead, we will create a .env file and we will save our OpenAI's API key. And to load that OpenAI's API key, we will have to create a small config.py file inside our source directory. Now inside this config.py file, I am pasting this code. It is a small code snippet. Here we are just importing the OpenAI's API key. This code snippet will load the environment variables and it will grab our OpenAI's API key. And from here, the API key will be available throughout our project. This is clean and reusable. Okay, the config.py file is done. Now let's actually build our first LangChain's pipeline. This is going to be the star of the show. Let's create this file. I am naming it chatbot.py. This file will be inside this instant trivia bot directory, which is inside the src directory. Okay, and this is going to be our main application. To save the time, I'm pasting the code here. You can see we are importing the time and async IO because today we are doing both sync and async streaming. And this rich console, this one is just for pretty output in the terminal. All that colorful text and that bold text and all that stuff that makes you look like a hacker from a 90s movie. Then the LangChain bits and str output parser. This is the simplest parser ever. It will take the model's output and converts it into a plain string. And of course, we will import this OpenAPI's API key which we have loaded inside our config.py file. So guys, now it's time to code. First of all, let's create a console object using the console class which we have imported from this rich.console. We will be using this console object in the code, guys. And we should define a prompt. Prompt is equal to chat prompt template dot from template. Here I am pasting the template, guys. You are a trivia master. Answer clearly and concisely. And this is the question. So this question is the variable, guys. Whatever question we ask, that will go inside this variable and the remaining thing stays constant. Now we need to initialize the model. Model is equal to chat OpenAI. This model needs an API key, so we will feed the OpenAI's API key to it. And need to we need to specify what model we want. For this purpose, we are using GPT 3.5 Turbo, guys. This model is sufficient for our application. We don't need any advanced model. And also we need to define the temperature. And temperature is, guys, the temperature will define the creativity of that model, guys. Suppose if we set 0, then the model will have 0 creativity. That means it will be purely deterministic. If we give it 100, then it is having maximum creativity. So for our application, we don't need creativity for this. It should be 0 creative. So we are giving the temperature as 0. And we should enable the streaming as true. So the model is ready. and we now want a parser. Parser is str output parser, and this one will convert the output of this model into a plain string. Now we will join them together. It's a chain prompt. This is the pipe operator, guys. Model chained with parser. Now what will happen is, guys, if we ask a question to this chain, that question will go inside this prompt first, and the existing prompt template will create a prompt which will have our question. So the output of this prompt will be given to this model. Now this model will take that prompt and give us the answer. That answer will be given to this parser, and this parser will convert that answer into a plain string. Now let's test this chain, guys. Let's create a question. Q is equal to, what is the capital of India? This is our question, guys. And to show you what's happening under the hood, let's invoke each of this component individually. So I'll invoke prompt dot invoke q. I'll save it inside a final prompt variable, and let's print this final prompt variable inside our terminal. And before printing it, since this is a poetry project, and the thing we have done inside this pyproject.pyml is, we said when we run poetry run start, it should go to the instant trivia bot directory, which is here. Inside it there is a chatbot file, which is here, and inside this chatbot file there will be a main function which we have not yet created, but we must create, so that when we run poetry run start, that main function will be executed. So let's create that main function, guys. Def main, and inside this main function we should say print final prompt. So let's save it and let's run poetry run start, and you can see this prompt, guys. You are a trivia master. Answer clearly and concisely. Question is, what is the capital of India? So what we created here, what we specified here, that this question got replaced with this one, guys. So this is what happens internally when we invoke this prompt. And after this prompt is invoked, this output of this prompt, that which is final prompt, will be given to this model. So when we are invoking the chain, first the question will go to the prompt, and then the output of that prompt, the output of the prompt is this one. This one will be given to the model. So the model GPT 3.5 Turbo will take this prompt. You are a trivia master. Answer clearly and concisely, what is the capital of India? So the model will answer. It will say it is New Delhi. So that New Delhi will go to this parser, and this parser will convert it into a plain string. So that's what happens. Let's directly invoke this chain, guys. I'm replacing this prompt with chain final answer. Let's save it, and once again run the poetry run start. So it said New Delhi. We got the answer. But in this project we are not going to use this invoke, guys. We are doing this project specifically to understand a method called stream. Both the invoke and stream, both of their aim is to give the answer, guys, but both of them act in a different way. The chain.invoke will give you the whole answer at once. It is suitable if you don't care about the user experience. And chain.stream method, it will feed you the tokens as they are generated, just like the subtitles in the Netflix. As the actor speaks, the subtitles will be generated. In the same way, this stream method also gives you token by token inside the terminal. And if you run this directly, we will not get the answer we expected, guys. Let's save this file and check it once. See, we will get this one. This funky looking output, this is not the answer of our question, guys. This is just a Python's way of saying this is an object which produces the values when you loop over it. That means to get the answers, we need to iterate over it, guys. Then only we will get to see the output. If not, it will output only this generator object. So to render this output, we need to run a for loop. Let's do it. Console.print. Now we are using the console object, guys. This console object is what we have initialized here. This is imported from rich.console package. Its purpose is to beautify the text inside this terminal, because everything looking white is not easy to look and understand, guys. So to make this beautiful, we use this console, and you will see I have created this bold green inside the square brackets. This is just like an HTML tag, guys. Whatever we write inside this tag will be in green in color, and that will be bold. So we will just print the value here. VALUE. Value is this one. So let's save it and let's run. So you can see the answer of the question was just New Delhi. When previously we executed chain.invoke, it directly rendered the New Delhi in a single line at once. But now you can see it first rendered the new this token once, and the next token it rendered after a little bit of delay. That's what happens with this stream. If you want to see it clearly, we can also add a time delay. However, already it is having a little bit of time delay, but we are unable to notice it much clearly, guys. So we are artificially adding a time delay. Let's add 1 second of time delay, guys. Save it and let's run it again. So the invoke method will give you the answer at a time in a single moment. Whole answer in a single moment. It might wait before generating the whole answer. It might wait for some time and then give you the answer when the complete answer is ready. Since this is a smaller answer, we are not seeing much delay. Suppose if the answer is 5 to 10 sentences long, it might wait, it might take some time to generate that answer, and until then you will not see anything. And once it is generated, it will dump the whole answer on into your terminal. But the stream method, it's not the case with this stream method, guys. What it will do is it will give you the tokens as they are generated one by one, one by one, one by one. It will not wait until the whole answer is generated. Suppose the answer is of 5 lines and each line is having around 10 to 15 words. It will give you one word by one word. It will not wait until the whole 5 lines are generated. So that's what the benefit with this dot stream method, guys. Now let's make this code clean and organized. Let's first remove these 2 lines, guys. I am pasting a function here. Now what this function basically doing is, let me just run this function, guys, and I will explain you what's actually happening. Trivia, let's save it. Let's clear the terminal. Poetry run start. So this first line which you are seeing, instant trivia bot, this is printed because of this line. Console print bold green instant trivia bot. So this is bold and this is green in color, and it is printed by console.print. And this is the while loop. If I enter quit, this loop will be broken and we will exit. If not, whatever I type will be taken as input and stored and captured inside this Q variable. And that Q variable is the question. That question will be joined with, will be concatenated with this string, guys. Please answer in detail and slowly. Suppose if I ask it, what is the capital of USA? It is not just taking what is the capital of USA. Along with this, it is taking what is the capital of USA. Please answer in detail and slowly. Then the LLM will give us a detailed answer. The purpose of asking the detailed answer to this LLM is, guys, we will get to see the typing effect live in this terminal. So that's why we are asking, please answer in detail and slowly. We have also added a delay. Let's increase this delay, guys, 0.5. Save it. And here this is nothing fancy, guys. The style is white. That means the answer will be white. And this attribute is nothing but after each token nothing will be printed. If I place slash here, that means after each token slash will be printed. If I enter this one, that means each token will be printed in a new line. So for now let's keep nothing here, and let's ask this question: what is the capital of USA? Let it answer. C. The capital of United States of America is Washington DC, and we got to see the typing effect. This is how many advanced chatbots like ChatGPT work, guys. They use the dot stream method under the hood. Now it is asking me enter another trivia question or quit, because this is a while loop, guys. Let's quit for now. So this is what dot stream method is, guys. Now there is another method which is dot stream. This is something async related to this stream method. Now let's understand about this stream method in another function. Let's declare that function here. Let me just name it back to stream. I am pasting the function here, guys. This is the async function. I have named it ask trivia async. Let's name this one also ask trivia sync, guys. And since this one is async mode, it should be sync mode. SYNCMODE, sync mode. And we should also change the name here. If you observe carefully, guys, both the functions have no big differences among them. The difference is here it is using dot stream method, here it is using dot stream method. What this dot stream method does is, guys, it will also stream the answer, but it can stream answers to multiple questions at a time without blocking any one of them. You will see the full power of this stream method in the next file which we will be creating here. In that we will demonstrate the full power of this stream method, guys. So let me break down what's actually happening in this async function. As usual, we are printing console.print bold green instant trivia bot, but this time we mentioned async mode. Here we specified sync mode, and it is as usual capturing the input, and if the input is quit, the while loop will break and it will print the answer in cyan color just like the sync one. And the for loop, here we defined it with async keyword. We are using the dot stream method. We are passing the question by concatenating the same string which we concatenated here, and then we will print the answer in white color. And here also we are waiting async io dot sleep. Instead of using time, we are using async io because this is async function. And we are printing a new line, guys. Console.print, it simply prints a new line, and we are specifically specifying the full answer without streaming AI invoke. This is invoke in async mode, guys. Async invoke. In these two lines, what these two lines are doing is they are printing the full answer, the same answer which this stream is generating, but this is not streaming, this is invoking. That means full answer will be dumped at once. And a invoke, it's nothing but it is invoke but in async mode. That means it is async invoke. Now let's try running this function, guys. So in the main function we will replace it with ask trivia async. Let's save it, clear the terminal, clear. Let's enlarge this terminal, guys, so that we can clearly watch. Poetry run start.
1 hour later.
So guys, actually this one is an async function. We have declared it using the async keyword. So it's not correct way to run this function like this. we should write something like this, guys. A async io dot run. Yeah, this is how this function will be executed. We should save it and let's try again. We can see instant trivia bot async mode, and let's ask it a question. When did World War II happen? World War II occurred from 1939 19 whatever. It's generating the answer, guys. Let's You can see it's typing, and finally it is giving full captured answer. World War II happened from 1939 to 1935. It is invoked, and if you observe it, guys, if you want, you can rewind and observe this one. It got dumped at a time. It did not get typed one by one like that. It did not get typed, guys. This answer, it was just like typing, someone is typing, but this one is not like that because this is basically invoke but in async mode. No matter async or normal, the nature of invoke method is to dump the answer at once. The nature of stream method is to render the answer token by token. And currently you might not see a major difference between this sync mode and async mode, guys, but you will see the full application of this stream method in the next file which we will be creating now, where you will understand what this stream actually is. Basically, a stream is nothing but you can ask a stream multiple questions at a single time, and a stream will answer all those questions parallelly without blocking any of the question. It will render all the answers parallelly. And guys, I think we should also modify this main function because there are two modes in this chatbot.py file. One is sync mode and one is async mode. So we should be able to select any of the mode based on our requirement or based on our wish. So for that, I have modified this main function, guys. This function is nothing but if you execute poetry run start, if you execute poetry run start, it will simply run this function, guys, ask trivia sync. So the chatbot will be in sync mode. Oh, actually I have not saved this file. Now let's try again. Poetry run start. Now the chatbot is in sync mode, guys. And suppose if I execute poetry run start async, then the chatbot will enter the async mode. Here you will be seeing here. See, async mode. Because this logic works in that way such that it will read this command. If there is async keyword mentioned here, then the bot will enter the async mode. If not, it will be in sync mode. If you want to go a little bit deeper about this topic, let me explain you. These are the arguments, guys. Each word is an argument. Poetry, run, start, sync, everything is an argument. This poetry run is common in both of these commands. So both of them won't be counted. This one, its index, the index of the start is 0. And if there is any keyword after this, its index will be 1. So this particular async keyword is having its keyword as 1. This is an argument. The start is also an argument, async is also an argument. So if the argument of index 1, which is this one, it is having some length greater than 1, and also if that argument is async, then run this function ask trivia underscore async. Or else if the length is 0 or there is nothing after the start keyword, then simply run ask trivia sync. So that's the logic of this function, guys. So far our trivia bot works, but suppose you are organizing a trivia competition where 5 people are asking 5 questions at the same time, then your bot will be saying, please wait, I am answering this guy's question. Not cool, right? So this is where async actually matters. You can run chains in parallel and stream answers side by side. Now for this purpose, we will be using the dot stream method. And to see the full potential of this dot stream method, we need to create a separate file. Let's name it parallel demo, paralleldemo.py. I am pasting the imports here. There is nothing new here, just they are almost the same like the chatbot.py. And this async.io is the star of our show. There is .console is for beautifying the terminal, and this LangChain imports are as usual as chatbot.py, and of course our OpenAI's API key from the .config.py. Now this thing also remains same. We are creating a prompt template. We are initializing the model. We are also creating a parser. Now we have defined a chain. Now we need multiple questions to throw at our bot at one single point of time. So let's create an array in which we will be storing our questions. I am pasting the questions here. These are our 3 questions. We will launch all of them at once and watch them stream together. And we also need to create a console object from the console class. Let's now define a simple function, and obviously it's going to be an async function. Def ask question. It will take 2 parameters, guys. One is label, another one is question. Label is nothing but the question number, and the question is question itself, which we have listed here. All this. For now, let's just print the questions in our console.print. And now we need to call this function also. And for that, let's define a main function. And guys, now I'm about to write a code. I will explain what that code is after writing. Just let me write that code. Now what I have done is, in Python, this is called as list comprehension. Now what we are actually doing is, guys, you need to understand from this point. This is the list of questions which we have listed here. We are enumerating that questions, and on that questions, this for loop is running. And for on each question, there will be an index of that question which is I, and the question itself is denoted by Q. And on every question, this particular function will be built. I am repeating again, the function will be built, not executed, because we need 3 functions to be executed parallelly, not one by one. If we execute a normal for loop, guys, the function will be executed one after one, step by step. But we don't want that. The purpose of this particular file paralleldemo.py is all the functions, all the questions should be answered parallelly at the same time. So for that purpose, we are building the tasks. These all are going to be the async tasks. Now, what this particular thing does is, it will create a list of tasks which will look like this kind of list. Now, this list is having the functions, their parameters. It is not function calling, guys. We are just creating the task. We could have written this task directly instead of this one, guys. But suppose if there are hundreds of questions, we cannot write it manually, right? So for that purpose, we use this list comprehension where the tasks will be created dynamically. And to execute these functions, we need to write wait. This single line will collect all the tasks which are listed inside this array and execute them parallelly at the same time, not one by one. So ultimately, all the tasks are getting executed at a single point of time. So we can delete this one, and to run this code we need to define a run function also, def run. And since this is an async function, we need to import this async, import async io inside it, and async io dot run main. So let's save it. And in pyproject.toml also we need to define command. Let's define it as parallel. This means if we write poetry run parallel, the file which is inside instant trivia bot directory with name parallel demo, and inside it there is a run function that will get executed. So let's run it. We got an error, guys. Ask questions missing one required position arguments. Let me check. Yeah, we should pass this queue outside the quotation marks, guys. It's our mistake. And there should be a comma. Now let's save it, clear the terminal, poetry run parallel. You can see the questions are printed. Guys, now the real game starts. Now we need to print the answers of our questions also. So console.print, and let's also add colors to them so that it becomes easy for us to separate which question is which one. And for each question we need to keep its own color, guys. So we also need to create a list of colors. So colors is equal to, now this function should also take that color as parameter, and that particular question and that particular answer will be printed in that color. So for that we need to surround this thing with a rich tags. See, it's not something fancy, guys. This is very simple. Now suppose the color is cyan, which we have defined here. Suppose if it is cyan, which is almost like blue, which you can see here, guys. This is what cyan is. If the color is cyan, whatever is inside this tag, you can see the square brackets, right? So whatever is in between this thing, that will be printed in that color. Okay, if it is yellow, this whole thing will be printed in yellow color. So let's beautify this one also. Instead of yellow we need to replace it with color parameter. And also here we need to pass the parameters. So basically I is nothing but the index. If the index is 0, 0, we are doing a modulo operation with the length of the colors list. Here the length of the list is 3. So the length of the list is 3, and 0 divided by 3 gives the remainder 0 itself. So for the first iteration the color will be cyan. That means for our first question, the question and answer will be printed in this color, and the second question, second answer will be printed in this color. The third question, third answer will be printed in this color. Now we will be implementing the dot stream method. Async for chunk in chain dot stream. We will pass the question inside it. So we have passed the question, and for each question we should print the response. And we will wrap the response in this text object, guys. Text is nothing but, this is a class which we have imported from the rich library. You can see it here. This text object is nothing but, it represents a string attached with few styles. That means whatever the string we pass here, we can add styles to them. So here we are passing the chunk. It will have a style. Let's give it the color, the whatever color it's passed here, that color will be given here, so that the answer will also be in the same color. And we will also specify each chunk should end with an empty string. Let's save it. Poetry run parallel. So you can see the output, guys. The first question is rendered blue in color. That means the answer of the first question is also those chunks which are blue in color. It parallelly rendered the answers of all the questions side by side. This is a chunk of the third answer. This is another chunk, and this is the chunk of the first answer. This is the chunk of the first answer, and whatever you are seeing in pink in color, all of this is the answer of the second one. So this is what a stream method can do. It gave the answers parallelly. It did not wait for each question to complete. If we have used the dot stream method, the process would be: first the LLM would answer for the question 1, and then it would move to the question number 2, and then for it would move to the question number 3. But since we are using dot stream method, it parallelly provided the answers for all the 3 questions. If we add one more question, it would easily give us its answer also. Let's ask it. And we should also add a color here. Let's add green color, because since there are 4 questions, we need 4 different colors. And let's save this file and execute poetry run parallel. You can see each chunk is delivered to us parallelly, and we got 4 answers. This is the last one, and it's not always fixed, guys. It's always random. You have just seen how the answers for these 3 questions were rendered. Now this time the pattern is not same. Previously the third question was answered first, but now the second question is answered first. It's just random. So this is how parallel answering of questions is done by any kind of chatbot. Suppose you are using ChatGPT and your friend is also using ChatGPT. Both of you are asking questions to ChatGPT at the same time, and ChatGPT will answer both of you at the same time. Under the hood, this is the logic which happens so that both of you will get the responses at the same time. It's not like you will get the response first and after you he will get the response. It's not the case. It's not like that. Both of you will get the responses at the same time. So guys, now let's dive into a new topic, and for that I'm creating a new file here. The topic is about output parsers. We have already explored string output parser. Now we will be exploring JSON output parser. So I'll name it structured output.py, because using JSON output parser we will be getting a structured output from the LLM. And for saving the time, I am pasting the code here. Now if you observe, there are no fancy imports, guys. This is the chat prompt template we have imported in every file so far, and this is the JSON output parser. We are also importing Pydantic. The combination of this JSON output parser and Pydantic is what forces the LLM to give a structured response. And if you observe here, we are defining a schema. Using Pydantic base model, we are defining this class named as trivia answer. It has 2 fields. One is question of string data type, another is answer. This is also of string data type. So here we are basically creating a schema and specifying that it should have 2 fields of string data type, and one field will be question and another field will be the answer. We have also given the descriptions, guys. And the remaining part is almost the same as chatbot.py. Here we define the parser as JSON output parser. Unlike in chatbot.py, we defined it as str output parser. Here we are defining it as JSON output parser. And we are passing the trivia answer schema which we have created just now. That means this parser's output must have 2 fields. One is question, another is answer, and both of them should be in string format. And we have also created a prompt template using the chat prompt template. And if you observe, we are also passing the format instructions, guys. That means in what format the output of the LLM should be, we are specifying using the format instructions. And as usual, we are passing the question also. And this is model definition, nothing new here. And this is the chain, and this is the result. Here you can see we are passing the question as what is the capital of Japan. We are also passing the format instructions as parser.get format instructions. This parser is this one which we have initialized here. So from this parser we are getting the format instructions, and those instructions will be passed into the prompt itself, and the prompt is now containing question and the format instructions. That prompt will be passed into this model, and that model will give us the output based on the instructions given. So we are simply printing the result here. Let's save this file, and to run this one, let's create another command in pyproject.toml as structured, and this file is located inside instant java dot, and the main function's name inside this file is run structured demo. So we copy this and paste it here. Let's save it, and poetry run structured. So we got the answer in the desired format, guys. It is a JSON object. It has two fields. One is the question, another is the answer. This is what the purpose of JSON output parser, guys. This can be achieved using this JSON output parser and the Pydantic library. Now you can use this data anywhere. You can save it in a database. You can feed it into a UI. You can also pass it to another pipeline. The choice is up to you. Let's take a look at what we have actually built today. We started with nothing but a file holding our OpenAI API key called config.py. From there we built chatbot.py, a clean LCEL chain which has a prompt, model and parser. We saw dot invoke for one-shot answers, stream for token by token, and stream for async magic, and we made it interactive with sync and async trivia modes. And there is parallel demo.py. Here we leveled up and flowed multiple questions in parallel at a single point of time. We have also color coded the output so that you can see the concurrency in the terminal at work. And there is structured output.py. Instead of giving us a simple plain text, we made the model to give us a structured JSON object, and that's the first step towards building agents that pass the data reliably between the steps. So in just one episode, we went from what is LCEL to running a trivia bot in sync, async, parallel and structured. That's a lot of ground covered. And in the next episode, we are stepping up again. It's a big one. LangGraph. That's where we move from linear chains to multi-step decision making agents with actual memory and branching logic. Basically, chains with brains. Hit subscribe, drop a comment, and let me know in the comments what's the coolest question you would test this bot with.